In this problem, we're going to find I0 using superposition. We'll use our problem-solving strategy entitled Applying Superposition. And if you remember, using that strategy, we're going to analyze the circuit with one source active, and then our response with all three sources active will be the response from each source acting alone, just added together. So here's our circuit. Remember when we for instance, if we analyze the response or the contribution from this source, we're going to set the other sources to 0. That would mean turning this to 0 would be an open circuit. Turning this to 0, this would become a short circuit. So let's start and let's find the contribution from the 2 milliamp current source to begin with. So here's our circuit. And if we look, this is really one node, so these two resistors are in parallel. Okay, and really these two resistors are in parallel. So now let's redraw the circuit a little bit differently so that we can see. This is the current I0 prime, 2 milliamps. Okay, by Kirchhoff's current law, this current is 2 milliamps, so we can get I0 prime by current division. So we have 2 milliamps. We want the current through here, so we put this resistor in the top. So the contribution from this source to this current is 4/3 of a milliamp. So now let's continue and find the contribution from the voltage source. So here's I0 double prime. Now let's, these two resistors are really in series. Let's redraw this circuit and combine those resistors. So we've redrawn it a little bit. Now, if we apply Kirchhoff's voltage law around this loop, we'll find that the voltage across this resistor is 12 volts with that polarity. And then by Ohm's law, this current is 2 milliamps in that direction. So if we look then, I0 double prime is going to be minus 2 milliamps. So here, by Kirchhoff's voltage law, this had to be plus and minus. By Ohm's law, we know the current has to be flowing in this direction, 2 milliamps. I0 double prime is defined in the opposite direction. So we have one remaining source. That's the 6 milliamp current source on the top. Now, let's redraw this circuit. Let's put these two in series. And here is I0 triple prime. Now if we notice, the voltage across that resistor is 0. Since the voltage across that 0, that tells us that I0 triple prime is 0. So this 6 milliamp source makes no contribution. So with all sources active at the same time, this would be our answer. So we'll have 4/3 of a milliamp minus 2 milliamps plus 0. And that tells us that I0 is minus 2/3 of a milliamp.